Hi everyone, my name is Raquel with adtmag.com and I'd like to thank you all for joining us. The topic of today's webcast is the Complete Guide to Observability, sponsored by Lightstep. Before we begin, I'd like to cover a few housekeeping details. There will be a Q&A session towards the end of today's presentation, so please type any questions that you may have in the Q&A box. Lightstep has provided a link in the resource section, so please take a moment to check that out. And additionally, this webcast is being recorded, so keep an eye out for a link in your email to rewatch the presentation or share it with a colleague. So without further ado, I'll now pass the time over to Katy Farmer, the Developer Relations Manager at Lightstep, to get us started. Katy, take it away.
Thank you very much, Raquel, and welcome everybody. Today we are going to be talking about the complete guide to observability. So, first of all, hello. Thank you for listening. My name is Katy. I am a developer advocate for Lightstep. That basically means that when it comes to tough technical topics, my job is to make sure that people who use the product understand, people who want to contribute to open source aspects can do that. And like any questions from developers and feedback, they go through me. I'm always happy to chat, so you have a few ways to communicate with me here. We're going to cover a few things today. Now, if you see the title, The Complete Guide to Observability, I think, honestly, for that to be true, we would need like 8 hours, but we're going to get definitely a complete guide to observability, an overview. And I would love to hear questions about whatever we've covered or maybe things we didn't cover at the end. So let's go ahead and just jump in and start talking about what is observability. I don't know about you all, but this term started showing up in my life, sort of like, maybe it was like on Twitter, or I started hearing people say it at conferences and talks. I even started seeing it on like marketing materials at booths and like the vendor area at conferences, but no one was really explaining it. So I think before we talk about, what it means at Lightstep and adopting an observability platform, we need to narrow the scope. What are we talking about here? So this term comes from this idea of control theory. So this graphic, if it makes sense to you, like, congratulations. It doesn't mean a lot to me, and that's okay, right? Because what we're talking about this is the scientific, like Wikipedia definition of observability. It's how well internal states of a system can be inferred from knowledge of its external outputs. So think about maybe chemical distillation processes where you really don't have a way of knowing what is happening inside of that system. So we make some judgments about the system based on the external outputs. It started gaining traction with site reliability engineering. Sorry about that. I usually just say SRE. I don't know why I tried so hard. And SREs, we're trying to make sense of a lot of different services they didn't have all the context for. And so they found that this idea of control theory applied to them. But I don't know about you, but that didn't help me that much. What is observability? Let's do the sequel, okay, where we talk about what it actually means. Because we're not talking about control theory. We're not talking about chemical distillation. We're talking about software. So this is an important definition. Observability is the ability to navigate from effect to cause. For example, we might see this pesky error keep popping up in our applications. That is an effect. Very, very rarely is the error a cause. Most of the time, an error is just an effect of something going wrong. So in this case, we might see an error and be able to track it back to a misconfiguration. You might see increased latency. Things slow down and go from that effect to a new customer behavior. And I think it is important that we talk about why we're not saying cause and effect, right? The point of observability is that you don't know the cause. We largely only see the effects, and we usually see them in production. So if you knew the cause, you wouldn't need observability. You wouldn't need an observability platform. You would have the answers, right? This is about seeing effects in our systems and being able to track down where they come from and find their cause. So to give this a little more context, let's talk about another definition you might have heard of. I had certainly seen this floating around. So let's talk about the 3 pillars of observability, which are metrics, logs, and traces, which is basically, well, how do we know if something has gone wrong? We use metrics. And how do we know what happened? We look at the logs. And if neither of those worked, and we try traces. And these are 3 really excellent data sources. And they are absolutely like fundamental to observability, but they are not everything. They are really more like 3 pillars of telemetry. They're the ways that we can measure. They give us the data to help us navigate through this like mystery we're solving. But they each have limitations. They even have some flaws, and they're very situational. Metrics might be incredibly useful for monitoring CPU, but they may not help you figure out why an error keeps happening. They might tell you that an error is happening, but you might not be able to track it any further. So if you want to know more about why we think there's a little more complexity to those 3 pillars, you can watch this talk. It's by this guy I know. He's pretty cool, I guess. Okay, but like, how did we get to the point where we need observability? We went a long time without it. So what changed? Scale. I think you all are probably as tired of hearing that word as I am, because a lot of the people I hear say it are vague. And they just say, does it work at scale? And my answer to that is usually like, well, what kind of scale, right? What does that mean? Do you need to scale horizontally, add more machines? Do you need to scale in complexity? Like, what does scale actually mean? So let's talk about 2 different types of scale that are particularly relevant to observability. So in our first example, you can see on this slide, there's a small body of water, a puddle that I would probably jump in. Now we see a lake, a large body of water. And this is one kind of scaling. We call this scaling wide. That is, if you just keep adding water to the puddle, eventually you'll get a pond and then a lake and then maybe an ocean. And then after that, water world, I think. But even though you would say the ocean is a lot bigger than the puddle, the solutions scale sort of the same way. you just need a boat, just the size of the boat changes depending on the size of the body of water. So here's another example to really show the kind of scale we're talking about. This is a village. It looks nice. I'm sure like you could get a nice Airbnb there. This is, you know, a grouping of people, their homes, their work, their livelihoods. And here's a city. And this is what we call scaling deep. And the point here is that a city isn't just a bigger village. It's a completely different thing. It's not just the size that's changing. There's a new structure that didn't exist at all before. The way that you navigate a village is totally different than the way you navigate a city. In the village, well, you can probably see where you need to go. You might be able to just ask someone. In a city, you have all these limitations that weren't there before. You can still ask someone, but even they might not know. The way we gather information, the way we find someone we're looking for, it doesn't just require more time when we're scaling deep, but it requires totally different tools. So we want to talk about observability in the context of these deep systems. Just like you can't use the same solution for a village and a city, you can't use the same tools for, say, a wide system or a deep system. Okay. So we talked about scaling deep, but what is a deep system? Like, think about all the things at work that you are responsible for. I'm not going to take a super long pause, but, you know, catalog them. If I had to list all the things I was responsible for, it would certainly take me longer than this. And then think about the things you can control. Our industry moved towards distributed architectures in the last, well, I don't know how many years, but we started using microservices and containers and all of these separate business units within an organization. So suddenly, we have a lot of things we're responsible for and only this tiny piece, our own little business unit that we can control. And the thing is that these microservices, they're not truly independent. They have to integrate with each other. They rely on each other. And that means that we have to think about how do we make our systems integrate and be reliable and support the rest of the system. When we think about the depth of an architecture, or say the number of independently managed layers in an end-to-end application, including, you know, microservices, monoliths, you know, cloud services, what have you. Deep systems are the production architectures with 4 or more of these independently managed layers. And I know that can still sound a bit like a lot, but how do we know? How do we really know if we have a deep system? Well, check Slack. For instance, I'm going to wait for the node to restart and hope that solves everything. Good idea, Mark. Or, where's Alex? I'm dealing with the PO and they're the only one that can debug this. Or even, that was on a dashboard, but I can't find it. I don't know about you, but like, I have seen these messages all the time. These are signs that we're dealing with a degree of complexity in our systems that makes it hard for people to navigate, be productive, and find their way to solutions. And you'll also kind of notice a theme here is that these are really inefficient ways of dealing with the problem. I mean, I dream of having all of my Slack messages answered within 1 minute of me sending them, but it rarely happens. So we have to think about how the solutions we offer address these kinds of deep systems. Because traditional tools weren't built for deep systems. I have spent a lot of time scrolling through dashboards and sifting through logs. And I would say that for a lot of that time, I even thought I was helping and making progress, only to later find out that no, I was nowhere close. Because in a deep system, requests often cross the boundaries between our services and teams, which means that these conventional tools, they break down. Now, traditional monitoring tools are helpful when you know what to monitor, but when you're looking for observing a system as a whole, then it's insufficient, basically. This is where observability really comes in handy. Because you need to observe what we like to call the unknown unknowns, right? You don't know what you don't know. So all the time I spend sifting through logs thinking I am absolutely on the right track. I just need to go back 5 more minutes. All of the things I didn't know about what was actually wrong in my system could have helped me spend my time wiser, find the solution faster. But traditional tools generally revolve around telemetry source, which are the things we talked about before, right? Metrics, logs, traces. And these solutions can be pretty expensive. A lot of them are data volume based, right? So if you pay for your logs based on volume, first of all, I'm sorry, I hope you're doing okay. And you know that you have to be careful with what you monitor and where you add telemetry, because every piece of that adds to cost. They also can be expensive in the overhead they create, or they're limited by the language or frameworks they work in. And they can feel really disjointed. I might have metrics going to a dashboard, logs I have to see in the console, traces through a separate tool entirely. They require a lot of context switching, which as developers, we kind of hate. Because again, every time I have to switch context, I have to prepare, remember all of the things that oh, right, the metrics, we do that through this service, and I can just go find the URL for the dashboard. That's all work. Even if it's not heavy work, it all adds up. And it adds up until the costs are huge. There's more time spent on-call, looking through data sets, trying to find, the root cause of a regression, which causes decreased development velocity, because again, not only are us developers spending our time doing that root cause analysis, but we also end up being a little more afraid to ship changes. A big failure can affect your team's confidence overall, especially when you thought I know how this is going to go because I wrote it and it's so good. It can be hard to come back from that. And it can cause fatigue in your organization. Some resentment too, because you're like waiting and relying on what we call tribal knowledge, right? You say, oh, Alex is the only one that knows the answer to this. So if he doesn't tell me, there's no way to solve it. Well, what if Alex is on vacation for 3 months, right? Or what if Alex doesn't work here anymore? These are problems we still have to address. So your application is getting deeper. It's getting more complex. And if you don't believe me, well, that's okay. Well, let's talk about your stack. This is the best kind of stack, although not the one I mean. Your software stack. And it doesn't really matter if we're talking about Python or Java or .NET. We're talking about how the software you and your team write fits with the software developed by the rest of your organization, or even, others like outside of the organization. Just begun, then you know what I'm talking about. Because your team and your services, they have become cogs in the machine. Maybe you have a diagram like this that tells you how your services fit into the machine. Maybe you're already building on Kubernetes or functions. So no one builds or deploys software in isolation anymore. So even if you're not running the latest version of Kubernetes or developing using serverless, chances are you still have a deep system. There's still software that you didn't write and that you don't control, but that you depend on. This could be because you're building in the cloud. This could be because you're using open source software as part of your production system. And it could be because your third-party APIs are part of your application. Because, again, nobody builds in isolation anymore. It's just not plausible. All of these things lead to layers of distinct ownership, and you might own this service at the very top. Or you could own it in the middle. It doesn't really matter. And, well, honestly, in the middle might be worse. But in any case, you've created these interdependent components, and you need something to help you understand that interdependence. And that is observability. Okay, so if you're not working in deep systems right now, you probably will be soon. Think of all of the ways your system can grow in complexity right now. So let's take a slightly more pragmatic view of observability. Let's see what it can really do for us. The right observability solution should hit on some important points. You should be able to easily see and understand your distributed environment. This is the main problem we're solving, right? We live in these deep systems, and we need help understanding them, navigating them, and understanding their interdependence. So it should absolutely be able to show you what your distributed environment looks like. Your observability solution should also immediately pinpoint performance regressions. You should know as soon as possible that things are going less than great. This solution should enable developers to ship with confidence so that you know that, well, even if my code isn't as perfect as I imagined it to be, I'll know very quickly. It should also enable the easy sharing of that information. After a deployment, I might be able to see the regression right away and then realize that maybe it's with someone else's team. I want to be able to share that information as quickly as possible. Your observability solution should also keep context. Context is a really important piece of observability, because when we talk about these deep systems, these complex systems, everything we do requires context. And once you've lost that, nothing quite makes sense. Nothing has an apparent solution unless you know all of the various interdependencies and effects it can have. And your observability solution shouldn't miss an insight. If there's an opportunity to learn, you want to know about that. You want to know about the unknown unknowns. So now we're talking about, ta-da, Lightstep. Maybe you felt this coming. I mean, I do work here, so I'm a little biased, but my job as a developer advocate is to always hear your feedback and to be as unbiased as I can. So let's talk a little bit about observability with context. Lightstep's approach is to use automatic deployment and regression detection, system and service diagrams, real-time and historical root cause analysis, correlations, custom alerting, easy setup, and no cardinality limitations. Like, really, I have seen a lot of tags. I've seen people push the limits and it's fine. You can send almost any combination of tags and operations and we'll be able to analyze it. So these are kind of the lists of things that I think correlate with what I want to see from an observability platform, right? They take some of the work out of it. They detect those deployments and regressions. Cool. They offer the diagrams to help you keep the context. You can do root cause analysis in the moment or on last week's outage. It's very flexible. And I think this is an important part of observability, because if the solution is too stiff, then you don't have those opportunities for insight. This is the Lightstep hypothesis engine, which might be my favorite phrase. So how do we actually do it, right? I'm telling you, we can offer these things, and I'm offering you no proof yet. So here's how it works. We collect 100% of your data across distributed systems, legacy monoliths, logging, open source products like Jaeger or Zipkin or mobile sources, right? And from there, we query the satellites you see in the diagram and then surface only what's most relevant to you. So basically what this means is we collect 100% of your data. We don't do any sampling straight off the bat. We want to be as accurate as possible. So we push all that data up into our satellites. And then from the satellites, the Lightstep solution can query the full data set to then surface the anomalies, to show you correlations, to do root cause analysis. And I think that our ability to collect 100% of that data is really something that makes us different. Because there's a lot of ways to sample data. Maybe you know about some of them. You can do something called head-based sampling, where you decide in the very beginning of a workflow what you think is going to be important. You can do tail-based sampling, which means the opposite. You can decide at the end of a workflow which data you're going to keep. But those all make some assumptions that you know what you might need. And they're perfectly valid and useful sampling techniques. But in this world of observability, we're often dealing with the unknown. So we want to keep 100% of that data so that then from Lightstep, we can then make decisions in real time on the entire data set to make sure that anomalies are preserved, that correlations are correct. The more data we have, the more accurate we are. So let's talk a little bit about some of the hot goss on Twitter. I'm so impressed by Lightstep. Finding the bottleneck and latency issues was easy. A couple of hours to debug, and I ended up improving my app performance by 70%. Wait, what? Yes, 70%. Wow. I'm not doing a good job capturing the all caps, but you'll appreciate that I'm not yelling. So, and I think, our ability to help people improve the performance, and I think for me, maybe more importantly, finding those bottlenecks as a developer is the most satisfying sort of feeling. It's nice that performance is improved, but I like knowing that the, problem spots are taken care of. This person says, debugged a production issue with Lightstep, new correlation feature in seconds. Really makes me wonder what's possible with distributed tracing when you start reasoning about traces in aggregate. This makes me wonder what's possible too. I like any product that makes people wonder what's possible. Because if we're showing them hey, there's more you can do here, then that means that we are successfully cornering that insight we talked about. Let's dig into what we don't know. I'm not going to read all of these out loud for you because I believe that you can pause this later if you want and read them. But I think it's important to know that people do talk about the product and that they're happy, right? Because yes, you care about observability. You care about what it means for you and your team and your system. But in the end, when we choose tools, when we choose vendors, we need and often rely on other people we trust to tell us that this works. So in the spirit of that, I want to tell you a little bit about some use cases because this is the juicy bit, right? So let's talk about our friends at Twilio. When we first talked to Twilio, they said they wanted to identify traces of specific noteworthy events. And that their logging solutions could answer basically who, what, and where the things happened, but not why. And I think it's great to be able to figure out, who, what, and where. But if you don't know why, then it will probably happen again. So they were continuously analyzing the transaction performance data generated by more than 40 core services, right? And they wanted a solution that wouldn't create overhead for them. They wanted what we talked about, this big macro view of their system so they could understand all of the moving pieces, but also a micro view of their services. And they also wanted to make sure that their developers were focused on building features and not building, monitoring. I say this a lot. Which is that a tool has to be easy to use because like I already have a job, right? You already have a job. Your job is to like build features or manage deployments. Every tool we introduce has the potential to be another job we're responsible for, which we don't need. So Twilio really wanted to make sure their developers were focused on, building features, making Twilio cool, and not so much on the tool. So with Lightstep as their observability solution, Twilio was able to go from an average root cause analysis investigation time of 40 minutes to under 3 minutes. Let me say that again for the people in the back. They went from 40 minutes investigating root cause analysis to under 3. And that saves the team nearly 20 hours each week. And also make sure the developers only have, the one job to do, not another job to manage the tool or to investigate root causes. Okay, now let's talk about Under Armour. Because I think it's really interesting to talk about system visibility. Because, I've sort of like hammered home this idea that these complex systems are hard for us to see, right? So what does it actually mean to have this like system visibility? So the folks at Under Armour have said, one of the things we're really trying to do is to make it so our engineers are not afraid to be on call. Make it so that they're not afraid to ship code. Just take the fear out. We have a world where people are afraid to be on call, and that actually translates into other organizational problems. End quote. And Lightstep provides immediate feedback on any changes and the effect the change will make in order to like enhance that automated decision making. And that means that, yes, the people at Under Armour can ship their code confidently, be on call and not be terrified. That's all important. At Under Armour, we also talk a lot about context, because Lightstep shows not only the traces, but the context behind like what's causing the issues. I'll read you another quote. Quote, "It's more changing the attitude, changing the approach, changing the relationship between our engineers and our systems so that they're not afraid of lacking context. They're not afraid of making a change." End quote. I think we probably don't talk enough about what it is like to be the person who makes a change and destroys a production system. I know it's happened to most of the engineers I know. And sort of the difference with like how they feel about that experience is how difficult it was to recover from it. Because, if you can change your approach so that you're not afraid to make changes, ship confidently, then even if things go wrong, when it's easier to recover, there's not such lasting trauma. And I think also our friends at Under Armour talk a lot about finding the answer, right? Because Lightstep helps showcase data in graphs to pinpoint what is not performing well. They talk about getting to a place where they understand what the user is experiencing and how, sorry, I'm losing my train of thought because I get so excited about things getting destroyed, but focusing. Basically, they talk about how, the graphs in the visualization portion of Lightstep help them understand, what is the user experiencing and how can we fix it. And I think being able to go from the effect, which is all the way out with the user, to the cause in a single view, single pane of glass, as they say, experience is incredibly valuable. So forgive my hesitancy on the customer use cases. It's important to get the details right, but hopefully these are examples. And if you want to know more about the customers, then all of these are showcased on our website. And hey, speaking of our website, you can get started today with Lightstep. We have a sandbox, which I personally think is a pretty magnificent tool, which is that you can go in and see what observability looks like in practice with data that doesn't stress you out because it's not yours. Nothing is actually going wrong. But you can go through several scenarios in the sandbox to find a root cause analysis or dig through some traces. It's really a fun experience. And yeah, I hope you'll give it a try. But then I want to make sure we have time for Q&A. So let's head to that.
All right, awesome. So this is just a reminder to the audience to type any questions you have for Katy in the Q&A box. And also the link that Katy was talking about, the sandbox link, is found in your resource section. So, Katy, our first question is asking, how is Lightstep different from New Relic and Datadog?
Yeah, this is an excellent question. I think when you're beginning this observability journey, you have to compare vendors. There's really no getting around it, right? So here's what I would say the big difference is. We talked a little bit about that 100% data from all of the various sources up to the satellites. That's a big difference. We feel that a more complete data set is a more accurate data set and makes our analysis more reliable. But I also want to point out that these New Relic and Datadog are very much in this category of traditional monitoring. And I think they're very good at what they do, but that they are trying to adapt to observability after the fact. Lightstep is different for a lot of reasons because it's very flexible. It's built with this idea of deep systems in mind. And this satellite architecture that I showed a diagram of is unique to Lightstep. All that 100% data retention, being able to query it from those dashboards, honestly just makes for better analysis. Yeah.
All right. We have another question here asking about Lightstep and if it has an open source component.
Yeah, absolutely. So one of my favorite things to talk about is open telemetry. I encourage you all to go look at it. Go to the website, go to the GitHub, join all the communities. Open telemetry is a standard being developed to work in distributed systems and particularly with distributed tracing. Because we know that high quality telemetry is imperative to observability, right? And there hasn't really been a standard before. So open telemetry is in alpha right now. You can use it for a few key languages. At Lightstep, we have a hand in its development along with many other folks, and it is entirely meant to be an agnostic tool to work not just with Lightstep, but with whatever you are already using. So I love OpenTelemetry. I think the engineers who work on it are super smart and are definitely looking out for the community. And I would love to hear feedback, so go check it out.
All right. Katy, could you go more into the differences between APM and observability?
Yeah, of course. So an APM, for those who don't know, is application performance monitoring, I'm pretty sure. And I think it's interesting to think about the difference between monitoring and observability. We touched on it just slightly, but the difference with monitoring is that you kind of have to know what you're looking for. Basically, you monitor things you think like will be helpful. I might monitor my CPU usage when I try to run Kubernetes on my local machine, right? But observability is much more about not knowing what you're looking for and still being able to answer the question. So traditional APM is great if you know what you're looking for and you know what you want to monitor, but observability is much more about answering the question, what is going on here, when you have less context.
All right. Well, I think that's all the questions that we have for today. Katie, do you have any closing thoughts you want to share with the audience?
I want people to absolutely send us feedback if there's something missing from this presentation that you think is really important to observability and getting started. I would love to hear about it. And I think I also wanted to note, I saw that in the Q&A we had someone from Puerto Rico, so I just wanted to say hola, bienvenido, thank you for coming. And I think I saw one more question pop up in the Q&A.
Oh, yeah. So let's see. They're asking, how do you support and integrate Kubernetes clusters and or mesh? And so if I deploy a microservice in deep scale environment and I want to redeploy that microservice 2 levels back on the block and 3 levels back on another block, how do I know which is which and failures?
Okay. I'm piecing this together, Alan. Forgive me for 1 second while I read it again. I think that when it comes to Kubernetes, there's kind of an interesting story, right? Like you're spot on with your question, because it can be really hard to keep track of those microservices when you're deploying them on those different levels. But we do have a plan for that, and we do support and integrate with Kubernetes entirely. We are about to release this information right ahead of KubeCon EU, so I know we have a plan, and I don't want to get it wrong. But I will link you to it. I will send a link to Raquel to share to make sure that it's correct, because I don't want to get ahead of myself, as it were.
Okay, awesome. Another question came in asking, is data security a shared responsibility between Lightbox and the company?
Yeah, that's a good question. When it comes to security, I like to think that it kind of always has to be a shared responsibility in some ways. I mean, that's just like my personal opinion. But depending on your data sources, right? Like depending on like what security exists there, like when the data is in our satellites, then it's our responsibility. When it's in the sources, then it would be yours. But, you know, we're always looking for ways to make those processes easier. The short answer is yes, it's a shared responsibility. Again, once it's on the satellites, I tend to think that like we will help, but the customer usually hosts those satellites on their own premises, so it can still be there's still a large chunk of responsibility that stays with the client. Yeah, that's what I would say.
Alrighty, wonderful. All right. Well, I think that's all the questions now. Thank you so much, Katie, for sharing your expertise with us. And also thank you to the audience for attending today's webcast sponsored by Lightstep and presented by ADTmag.com. I hope you have a great rest of your day.